Do you know how chemists estimate the average molecular weight of fats or oils? It is by determining saponification value. Welcome back, students. I am Dr. N. Swati, your organic chemistry coach. In this video, I am going to explain saponification value, its definition, significance, and step-by-step analysis. Stay with me till the end of this video because this is one of the most important expected questions in your final examinations. Now let's jump into the topic. Value. So the definition for saponification value is, it is the number of milligrams of alkali necessary to neutralize the free fatty acids and to saponify the esters present in 1 gram of fat or oil. Now let us try to understand the meaning of this saponification value through its determination. The principle involved in the determination of saponification value is neutralization, residual titration, or back titration. So let us see what we are going to determine in this saponification value. So fat or oil are nothing but triglycerides. That means they are triesters. And they also consist of sometimes free fatty acids as the impurity, which is the main one responsible for its rancidity or adulteration of the given sample, which I explained under acid value determination. Now the esters which are present in the given sample of fat or oil can be subjected for alkaline hydrolysis. So this alkaline hydrolysis is nothing but the saponification, which is mentioned in its definition. So upon saponification or alkaline hydrolysis, esters will undergo cleavage, as a result of which they give corresponding fatty acid as well as glycerol. Now along with the triglyceride or triester, the fat or oil is also consists of some of the free fatty acids. Because these free fatty acids are having acidic property, we can subject them for neutralization. That is, by titrating with base, we can perform a neutralization reaction so that the free fatty acids which are available in the sample will be converted to corresponding salt. That means both for alkaline hydrolysis or saponification and also to perform the neutralization of free fatty acids, here we will be using base. That is what is mentioned in the definition of saponification value. So it is the number of milligrams of base or alkali, which is nothing but potassium hydroxide, required to neutralize the free fatty acids and to saponify the esters present in 1 gram of fat or oil. So to determine how much of alkali is required to perform the saponification, that is alkaline hydrolysis, and also to neutralize the free fatty acids present in the given sample of fat or oil, we will do titration. That means we will do volumetric estimation. So here, to get to know about these two things, a known excess of potassium hydroxide will be added to the fat or oil sample. Then it is subjected for heating. If we want to determine only free fatty acids, then we can just titrate the given oil sample by using potassium hydroxide, utilizing an acid-base direct titration like acid value determination. But here, along with the neutralization of the free fatty acids, we want to saponify the esters which are present in the oil sample. So in order to perform the saponification, we need to heat the given oil sample by adding alkali. So whatever the remaining base is retained after heating process is back titrated by using standard acids such as hydrochloric acid using suitable pH indicator. For example, phenolphthalein. And also here we will be performing a blank determination to determine the saponification value. Now students, pause this video for a minute and try to write the reaction for this principle. So I hope by this time you might have written. So for your clarity, I am giving those two reactions here. So here the first reaction is corresponding to the saponification reaction, which I mentioned earlier. So this is the structure of fat or oil. So alkaline hydrolysis is performed. So it is a single step reaction where we will be getting glycerol. So this part will be cleaved as glycerol and the corresponding soaps, that is salts or fatty acid, will be formed as products. Okay, now coming to the second part, that is neutralization of the free fatty acid. So this is the general structure of the free fatty acid. Again, potassium hydroxide is added. So we get the corresponding salt. So these two reactions are corresponding to the two processes which I mentioned in the earlier slide. Now let us try to understand the procedure involved in this saponification value determination. So first step, as usual, we have to take the oil sample as per the monograph specifications. So weigh accurately about 2 grams of the sample to be examined and transfer into a reflux flask. It is not conical flask here. Why? Because we are going to reflux or heat the oil sample along with potassium hydroxide in order to facilitate the saponification process. That's why as soon as the sample is weighed, transfer the sample into a reflux flask. Okay, now you add excess of potassium hydroxide. So here we will be adding 25 ml of 0.5 molar ethanolic potassium hydroxide solution. Okay, now whenever we prepare potassium hydroxide in analytical titrations, it is usually dissolved in water. But because the given oil sample is water insoluble in nature, here we will be using ethanolic potassium hydroxide solution as the base here. Okay, now then add pumice powder or porcelain chips in order to avoid bumping during the reflux process. So as soon as potassium hydroxide is added, then attach the reflux condenser and reflux the contents on water bath for about 30 minutes. Now during this process, what happens? As soon as you add potassium hydroxide, neutralization of free fatty acids which are available in the sample occurs, and during this 30 minutes heating process, saponification occurs. Okay, that means esters will undergo cleavage. So at the end of the 30 minutes, all these two processes will be completed. That means your sample is now ready for the titration. Now at this point of time, add 2 drops of phenolphthalein indicator and titrate the contents of the flask immediately by using 0.5 molar hydrochloric acid. Once you get endpoint for this titration, note down the volume rundown as AML. Now again perform blank titration. So what is the meaning of blank titration? That means we will be repeating the same titration by omitting the sample. That means we need not to do the first two steps. So perform the blank titration by third step onwards. Okay, that means you will be adding 25 ml of 0.5 molar ethanolic potassium hydroxide and porcelain chips. Then boil the contents for 30 minutes, add phenolphthalein indicator and titrate by using hydrochloric acid. Now in this particular titration, whatever the volume rundown is there, consider it as BML. Okay, so A is the initial volume, okay, and B is the value corresponding to the blank titration. Now what is the end point of the titration? So when you add phenolphthalein indicator, what is the pH of the solution? If you see, there will be excess of potassium hydroxide will be left over. So due to the presence of excess of potassium hydroxide, the pH of the media, it becomes basic. Now in the presence of basic medium, phenolphthalein shows pink color. That means whenever you add phenolphthalein indicator to the reflex flask or to the conical flask, the solution immediately it becomes pink. Now once you start titrating with HCl, slowly whatever the leftover potassium hydroxide will be there, that will undergo neutralization. Now once neutralization point is reached, now if you keep continuing the titration, now whatever the excess drops of hydrochloric acid added are there to the flask, because of this excess of hydrochloric acid, the pH of the environment, it becomes acidic. Now in the presence of acidic pH, phenolphthalein shows colorless. That means the end point in this reaction will be pink to colorless. Now, whatever the A value and B value are there in this particular titration, we will be substituting these values in the formula given for the saponification value. Now the formula for the saponification value is 28.05 multiplied by the titer value. Here the titer value means it is the difference between the blank titration, whatever you are getting in the blank determination, and the actual value, actual assay value, whatever you are getting. So we'll be doing B minus A, that is considered as the titer value, multiplied by the molarity of HCl used, divided by weight of the oil sample, multiplied by molarity of standard hydrochloric acid. So again students, here also two molarity terms are used, one in the numerator and another one is in the denominator. Because hydrochloric acid is a secondary standard, whenever we use hydrochloric acid in the titrations, so in the same determination, that means along with the determination of saponification value, you have to perform the standardization of hydrochloric acid also. So whatever the molarity value you are getting for hydrochloric acid upon standardization, so that value is the actual molarity of hydrochloric acid used. So that value comes in the numerator. Now, whatever the standard hydrochloric acid molarity is mentioned in the IP, okay, so the IP, it suggests to use 0.5 molar hydrochloric acid. So this value comes in the denominator. So that is the difference between the molarity terms in the numerator and the denominator. So here 28.05 is the equivalent weight factor for potassium hydroxide corresponding to 0.5 mole. So by substituting the titer value, molarity terms and weight of the sample in this particular formula, we can determine the saponification value of the given oil or fat sample. Now that you have learned the definition of saponification value and its determination, which includes principle and procedure, now let us try to understand the significance of this saponification value. So higher or lower saponification value indicates adulteration of the sample. That means each and every fat or oil will be having its own characteristic saponification value. Any deviation from this value indicates adulteration of the sample. And this saponification value also gives information about molecular weight of the fats, because lower the saponification value, higher will be the molecular weight of the sample. So indirectly we will come to know the molecular weight of the given fat or oil sample. So by determining this saponification value, we can determine how much of alkali is needed to perform this saponification of the ester. So because upon saponification of esters, we will be getting soaps. And this particular information will be useful in soap manufacturing industry. If this video is useful to you, then give it a like and subscribe my channel so that you won't miss my next coming chemistry concepts. Thanks for watching and stay tuned to my upcoming videos.